So you have to take organic chemistry. You've heard that organic chemistry is the second hardest college class, therefore it has a bad reputation. But organic chemistry is important. It is the biggest, most studied field of chemistry. Note that 99% of all living organisms and more than 99% of all compounds contain these elements. So as a result, there are many organic compounds, so far 50 million known in the world. To learn organic chemistry, we want to look at the structural features of a molecule and determine what atom or bond in that structure is reactive. Then we can figure out how a reaction occurs to predict the products of a reaction. Chemists are synthesizing new compounds every day, so you want to apply your knowledge of structure and reactions to synthesize new compounds. And finally, we want to understand the mechanism of reaction because that will help us understand reactions and design better syntheses. So stop the video and fill in this blank. So organic chemistry is the chemistry of carbon. And we'll look at properties of carbon. Remember that carbon has 4 valence electrons, which means that there can be 4 bonds to carbon. There can be single bonds, double bonds, and triple bonds to carbon. And because there's 4 bonds to carbon, organic compounds can form chains, rings, and sheets. Ethylene is one component of petroleum, and we will learn in organic chemistry how to convert ethylene to ethanol, polyethylene, which is a type of plastic, ethylene oxide, and ethyl chloride. The organic chemistry of natural products is an important area of research. For example, bryostatins are potential drug candidates for various diseases. However, 18 grams of bryostatin 1 was extracted from 14 tons of B. naratina. Since it's not really worthwhile to extract bryostatins from these natural products, organic chemists have come up with syntheses of these compounds in the lab. As a student, do you expect to learn organic chemistry this way? Educational research shows that if you read a textbook, you only learn 10% of what you read. If you listen to a lecture, you only learn 20% what you heard. If you see and hear a lecture, you only learn about 50% of what you see and hear. So if you really want to learn something, you want to be able to write and discuss and experience, for example, in the lab, and teach someone else. I was a college student once, and I experienced all of these situations while I was sitting in a lecture. Maybe that's why I only learned 20% of what I heard in lecture. Einstein said that you don't really understand something until you can explain it to your grandmother. So, what percent do we learn from what we teach? And the answer is... So stop the video and identify what is the best way for you to learn organic chemistry. This is a quote from the New York Times article. You can't memorize all the possible answers. You have to rely on intuition, generalizing from specific examples. This skill, far more than the details of every reaction, may actually be useful for medicine. So, to get good at something, you want to apply these 3 factors: deliberate practice, insightful coaching, and motivation. So that insightful coaching is from your teacher. So another good way to learn organic chemistry is to work with a group of students. Studies show that students who work in cooperative groups tend to get better grades and enjoy the course more than students who work individually. Now, it's important to learn to work in a group because when you work in industry, you will work in teams, and it will also help you build and develop social skills. Problem solving is what you do when you don't know what to do, otherwise it's not a problem. You'll be learning and applying problem solving strategies in organic chemistry as well as in your other classes. The ideal problem solving model is this one: you understand the problem, devise a plan, carry out the plan, and look back. Problem is, problem solving is never so smooth. Here is a more realistic problem solving model. So you read the problem again, Write down what you think is relevant. Draw a picture, make a list, write an equation, a formula. Try something. This is very important. Then try something else. See where it gets you. Test intermediate results to see whether you're making any progress. This is also very important. Read the problem again. Write down an answer. It may not be the answer. Test the answer, see if it makes sense. Start over if you have to, and celebrate if you don't. So there's a lot of trial and error in problem solving. So it's okay to make mistakes. Just try again.